Hello, lovely people. My name is Tete Jacob Sirichi. Welcome to my online tutorial. Our discussion on discrete mathematics and relation for that matter will be on Hesse diagram. Before the video ends, I will tell you the first person who discovered Hesse diagram, the do's and don'ts when we are drawing Hesse diagram. Then we'll learn how to draw Hesse diagram for a particular set. This will be a very interesting engagement, so please be my guest. So the first person who discovered Hesse diagram was called Hesse. So Hesse was the first person to discover Hesse diagram. So Hesse diagram was discovered by Hesse. What is Hesse diagram? Hesse diagram simply means that the drawing of a line from one element of a set to another because that element relates the other. So if let's say 2 relates 4, then we just draw a line from 2 to 4 because the 2 relate 4. So that's all about Hesse diagram. However, there are some things we need to avoid when we are drawing Hesse diagram. And what are those things? In drawing Hesse diagram, we need to avoid 1, arrowheads. We need to avoid transitive property of graphs. Then we also need to avoid the reflexive property of graph. When we say arrowhead, for instance, if let's say 2 relate 4 and we are drawing a line from 2 to 4, we need to avoid arrowhead as we used to do when we're doing directed graphs. So we have to avoid arrowheads. So that's the first one. We need to avoid transitive properties. That's if let's say 2 relate 4 and 4 relate 8, okay, we need not to draw, after we draw 4 relating to 8, and maybe 2 also relate 2 also relate 8. We need not to draw a line from 2 to 8. It is with the belief that since 2 relate 4 and 4 relate 8 already, it means that 2 is already connected to the 8. So we need to avoid that transitive property. Then we need to avoid reflexive property of graph. What is reflexive property of graph? We need to avoid self-loops. So self-loops are not in the drawing of Hesse diagrams. So I hope you get that. So now we take a sample question and see how we can draw a Hesse diagram for a relation defined on a particular set. So our first example says we should draw a Hesse diagram for the relation R equal to the ordered pair A, be a member of the relation where A divides B, defined on the set S with elements 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. So how do we draw a Hesse diagram for this? So when we say A divides B, that means A is a factor of B. So that means we'll draw what? We'll draw a line from one element of this set to the other with the fact that that element is a factor of the other. So that's what we are going to do. So in drawing it, you have to position your dots like this in order to write the number of the set. So first, you locate those elements with only one factor. So you see that 1 is having only one factor. I can write the 1 here. Then the next step will be those that are having 2 factors or are prime. So you can see that 2, 3, and 2, 3, and 5 are prime. So we can put them. Then the next, those that have 3 factors. So you can see that 4 is having 4 factors. 4 is having, the factors of 4 are 1, 2, and 4. So 4 is having 3 factors. What again is having 3 factors? We have 15, which is 1, 3, 5, and 15. So 15 is having 4 factors. So you realize that 1 is having only 1 factor. The next that are having 2 factors are 2, 3, and 5. That are in this set. Now, which of the set have 3 factors? Is 4. The factors of 4 are 1, 2, and 4. So 4 is having 3 factors. It will be a little bit above the 2, 3, and 5. The next one is 6, 10, and 15. So, 6 is having how many factors? 6 is having, the factors of 6 are 1, 2, 3, and 6. The factors of 10 are 1, 2, 5, and 10. And then the factors of 15 are 1, 3, 5, and 15. So you realize that all of them have 4 factors. So they can be in line. We can say this is 4, then this is 6, then 10, then 50. I hope you get that. Then the next that have more than 4 factors, that's 12 and 20. They have more than 4 factors, so they are the next. So 12 here, then 20 there. Then the next that have more than the factors of 12 and 20 is 30. Then the next one, or the last one, will be 60. This is how we position before we start drawing. So you see that 1 is a factor of 3, 1 is a factor of 5, and 1 is a factor of 2. I hope you get that. So the next one, we have 4. 2 is a factor of 4. So someone will say 1 is a factor of 4. Yes, but since 1 is already connected to 2, and 2 is connected to 4, it means that when we are listing the factors of 4, the factors of 4 will be 4, 2, and 1. I hope you get that. Then the next one is 6. What are the factors of 6? 2 is a factor of 6. So we draw an arrow from there. 3 is a factor of 6. We draw an arrow to there, that place. Someone will say 1 is a factor of 6. Yes, but we won't draw an arrow from, we won't draw a line from 1 to 6. Because 1 is already connected to 3 and 3 is connected to 6. Or 1 is already connected to 2 and 2 is connected to 6. We don't have any problem. So when we need the factors of 6, the factors of 6 will be 1, 2, 3, and the 6 itself. I hope you get that. So now let's go to the 10. So 2 is a factor of 10. 5 is a factor of 10. 3 is not a factor of 10. So we won't draw. 4 is also not a factor of 10. Neither is 6 a factor of 10. So now 15. 3 is a factor of 15. 5 is a factor of 15. I hope you get that. So the next step, we go to 12 and 20. So we see that 4 is a factor of 20. Yes, 2 is also a factor, 4 is a factor of 12. 2 is also a factor of 12. But since 2 is already connected to 4 and 4 is connected to 12, we don't have any problem. See, 6 is also a factor of 12. I hope you get that. Then 3 is also a factor of 12. But since 3 is connected to 6 and 6 is connected to 12 already, we don't have a problem. So we need the factors of 12. The factors of 12 will be 12, 4, 6, 2, 3, and 1. I hope you get that. The next one is 30. So we see that 6 is a factor of 30. So what again? 10 is a factor of 30. Then 15 is also a factor of 30. I hope you get that. So in that order, 12 is not a factor of 30. Then 20, you see that 10 is a factor of 20. That's all. Is there any number here that is a factor of 20? Yes, 5 is a factor of 20, but 5 is already connected to 10, and 10 to 20. We don't have any problem. So we are still on 20. So what's the next step? You see that 4 is also a factor of 20. So we go like that. I hope you get it. The next step is 60. So 12 is a factor of 60. 30 is a factor of 60. Then 20 is also a factor of 60. Then this becomes our Hesse diagram for that relation. So if you look at it, when you need the factors of 60 will be everything that is connected to 60 and anything that is connected under it. So factors of 60 will be 12, 60 itself, 12, 30, 20, 6, 10, 15, 4, 2, 3, 1, and 5. I hope you get that. This is very interesting. We will solve one more example on this so that you'll be abreast with the concept. So our second example says we should draw a Hesse diagram for the relation R equal to the ordered pair AB, be a member of the relation where A divides B. Define on a set A with members 1, 2, 3, 4, 6, 8, and 12. So you can pause the video and try drawing a Hesse diagram for this After that, you compare your answers with mine. So we said in drawing Hesse diagram, first locate the members of the set that has only one factor. So 1 is having only one factor. Then the next one, those that have two factors or are prime. So if you look at the set, it's only 2 and 3 that are having two factors. They are prime. So we have 2 here and 3 there. Then the next one, those that have 3 factors. So you see that 4 is having 3 factors. The factors of 4 are 1, 2, and 4. So it will be a little bit above those ones. Then those that have 4 factors. So you see that 6 is having 4 factors. 1, 2, 3, and 6. And 8 is also having 4 factors. 1, 2, 4, and 8. So we locate them as this as 8 and this as 6. Then the next or the last one is 12, which is having more than 4 factors. There we go. So the Hesse diagram is just saying that we'll draw a line from one element to the other because that element is a factor of the other. So you see that 1 is a factor of 3. You know, 1 is a factor of itself. But we can't have a self-loop because the Hesse diagram says we should eliminate reflexive property. So 1 is a factor of 3. 1 is also a factor of 2. Then 2 is a factor of 4. I hope you get that. 1 is also a factor of 4. But since 1 is already connected to 2 and 2 to 4, then we will not draw a line from 1 to 4. So the next step is 6. So what are the factors of 6? Remember the factors of 6 are 1, 2, 3, and 6 itself. So let's find out. So 1 is connected to 2. So we can draw to 6 because 2 is also a factor of 6. Then 3 is also a factor of 6. Here you go. I hope you are getting that. Then 4 is a factor of 8. 2 is also a factor of 8. But right, since 2 is already connected to 4 and 4 is connected to 8, then there is no need to draw a line from 2 to 8 again because we want to avoid that transitive property. The next one is 12. So you can see that 6 is a factor of 12. Then 4 is also a factor of 12. So 8 is not a factor of 12. So we will not draw an arrow from 8 to 12. Then this is how our Hesse diagram will look like. So when we need the factors of 12, the factors of 12 are 12 first, 4, 6, 3, 2, and 1. When we need factors of 8, the factors of 8 are 4, 2, and 1. The factors of 6 will be 6, 2, 1, and 3. I hope you get that. So this is very interesting. Now we'll learn how to draw a Hesse diagram for a subset of a particular set. So our third example says we should draw a Hesse diagram for the subset of the set R with members A, B, and C. So this set is having 3 elements. So how many subsets are we going to get? Remember, the number of subsets is given by the formula 2 exponent n, where n is the number of elements. So we can say that this set will have 2 exponent 3 subsets. So the set will have 8 subsets. So we need to locate that subset. So remember that we say an empty set is a subset of every set. And every set is a subset of itself. So we need the empty set first. We need all unit sets. All unit sets are subset of a set. So like this, A, B, and C. Then we need 2 member sets, A, B. We have A, C. Then we have 4, B, C. I hope you get that. Then the set is set A, B, and C. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. So we are going to draw a Hesse diagram for that. So in drawing the Hesse diagram, we look at the members of the subset. Okay? The subset that is having no elements. So that's an empty set. We have an empty set here. Then we can have the unit set A, because it's have only one element. You can have the unit set B, because it has only one element. Then we can have the unit set C because it has one element. Then we have those that have two elements. So we can have the set AB, we can have the set AC, then we can have the set BC. I hope you get that. Then the set itself, which is A, B, and C. So now we locate. If a set is a subset of another, we draw an arrow from that set to the other. So you can see that this is an empty set. An empty set is a subset of every unit set. So we can draw a line from the empty set to all the unit sets. So now look at it. Is A subset of AB? Yes. A is a subset of AB. The unit set is also a subset. But since the unit set is already connected to the set, and A is connected to that, then there is no need drawing a line from the empty set to that set. Then, is B a subset of this set? Yes, B is a subset. So we draw a line from B to that set. So, is C a subset of this set? No. Is A a subset of this set? Yes. So we draw an arrow from there to this. That's the set AC. Then is B a subset of this set? No. But C is a subset. So we draw a line from C to that. Is B a subset of this set? Yes. So we draw a line from there to here. Is C a subset of this set? Yes. So we draw a line to connect. A is not a subset of that, so there is no need drawing a line from there to this place. Now we find out, is AB a subset of the set ABC? Yes, so we draw a line. Is AC a subset? Yes, so we draw a line. Is BC a subset of that set? Yes, then we draw a line to connect. Then this becomes the Hesse diagram of this set. So the empty set here can be called the lower bound, and the set itself is the upper bound. When you want to find the lower bound and the upper bound of a Hesse diagram and lattice for that matter. So we'll end it here today. We have been looking at a Hesse diagram. We said the Hesse diagram was first discovered by Hermann Hesse. We look at the do's and don'ts when we are drawing Hesse diagram. Then we also learn how to draw Hesse diagram for some particular set. We'll end it here today. Please remember to subscribe to my YouTube channel, like and comment. It is the only way you can help promote my YouTube channel so that I can record more mathematical content for you. Until we meet again, my name is Kepsi.